Good morning, Algebra 2. We are going to cover Lesson 53, and this is a tough one, so hopefully you're following along. It's function composition, and we're going to be doing the lesson practice out of page 381. So function composition is when you plug one function into another for x. Now the notation for that can be two ways. So the function of g of x, or it can be the function open circle g and then x in the parentheses. Now, I keep telling you this, and I have some of you still doing this. The parentheses x does not mean you will be multiplying by x. This is function notation. This is saying plug the function of g into f where x is. That is what this is saying. This is not saying multiply f times g times x. That is not what this is saying. So we're going to jump in, and I'm going to teach it to you through the lesson practice. So page 381, and we're going to start on part A. Now part A gives us two functions. F of x equals 2x minus 9, and function g of x, which equals x plus 1, in parentheses, squared. Okay, now it's asking us to find f, and then it uses the parentheses notation, at g of x. So I'm going to color code this for you, make it a little bit easier. So here is f, and I'm going to use orange for g. So it's asking us to plug the orange into the yellow function where x is. Did you get that? So I'm going to rewrite this. So, and I shouldn't have changed color of pen. So notice I kept f on the outside, and inside I substituted with orange. Okay, so I'm going to write the directions. We are plugging x plus 1 squared into f of x where the x is. So I want you to watch this really careful. 2x minus 9. That is the yellow function. Let me highlight it. Now, I am plugging in, this is the yellow function, I'm plugging in the orange piece. So x plus 1 squared. So notice here is the orange. And now we're going to solve. Now simplify using order of operations. Please excuse my dear Aunt Sally. So parentheses first, so x plus 1 times x plus 1 minus 9. Okay, so now I've simplified that part. Now I have to distribute the parentheses. So x squared plus 1x plus 1x plus 1. Now I have to distribute the 2. And now combine like terms. Combine like terms. Okay, so my final answer is 2x squared plus 4x minus 7. Okay, now I'm going to continue to remember, it just means you're plugging one function into the other where x is. So let's try. We're going to do several of these, okay? So if you don't understand it after the first one, that's okay. Not many people do, so we're going to do a couple. So for part B, they said this time f of x is x squared minus 2, and g of x is x minus 4. They would like us to find, and they're going to use the different notation, f of g of x. Now, this means the same as f of g of x. So again, I'm going to color code here is x. That's the function of f. That's right here. And they want me to plug in g. So let's rewrite this. I have the function of f, and I'm going to replace g of x with x minus 4 so that you can see that into the function of f, I'm going to plug in x minus 4 where the letter g is. So here we go. The function of f is x squared minus 2, right? I'll highlight in yellow. So there's the function of x, but I'm plugging in x minus 4. Notice it's the second letter that gets plugged into the first. So it goes g of x into f. Okay? So now I'm going to simplify. Parentheses first. So x minus 4 times x minus 4. Don't try to do a shortcut there. Unless you can multiply it out in your head and not skip the two middle terms, don't do the shortcut in your head. Okay? So x squared minus 4x plus 16, and then bring down the minus 2. Now combine like terms, so my final answer is x squared minus 8x plus 14. Next one. So, part C. Now for part C is a little different. So for f of x, they've given us 3x minus 7. For g of x, they've given us 4x plus 5. And they're asking us to find f of g of 7. So I'm going to rewrite as f of g at 7. So here is my orange function, and I'm going to do that one first. And then this outside is here. Okay, so when I have a number, evaluate inside first. So I'm going to do the orange. So I have g at 7, so 4 at 7 plus 5. And then out here I still have of f, but I'm going to simplify this, simplifying parentheses first. So I get f at 4 times 7 is 28. 28 plus 5 is 33. So now I'm plugging 33 into f. So 3 times x minus 7. I don't know why I keep closing these highlighters. It doesn't make any sense, especially if I'm going to use them for every example. And then in here, 33. So 3 times 33 gives me 99 minus 7, 92. Not so bad, not so bad. Part D, they've given us two functions, f of x equals x plus 6, and g of x equals x squared. And they've asked, is f of g of x equal to g of f of x? So they're asking, do I get the same thing when I plug G into X as I will when I plug X into G? So I'm going to stop the color coding for this one. So I'm going to start with the first. I'm going to rewrite it, F at G of X. And this one is G of F of X. So I'm going to do this one first. So F of X squared equals X squared plus 6, which is just X squared plus 6. Then I'm going to do the second one here. So G of X plus 6 equals X plus 6 squared. And that gives me X squared plus 12X plus 36. Are these equal? No. So I want you to see what I've done. So if I labeled this yellow, so I plugged, whoops, why do I keep closing these highlighters? So in the first one, I plugged the orange into the yellow. For the next one, I've plugged yellow into the orange function. So hopefully you can see that. I color-coded. That's the first 4 examples. So from here on out, I'm not going to do the color coding. So for E, F of X equals 2X minus 1. G of X equals negative X. And they'd like us, sorry, I just dropped something. They'd like us to find in part E, they'd like us to find F at G at negative 1 and G at F of negative 1. They'd like us to find both. So here we go. For this one, I'm going to start with the inside, so that would be negative 1 times negative 1, right? Because this right here can be written as negative 1 times X. Okay, so this gives me F at 1, which is then 2 times 1 minus 1, which is 1. The reverse, I'm going to do G at, so this is here. So G at F at negative 1, that'd be 2 times negative 1 minus 1. I'm doing the inside first. So, and then this one here. I said I wasn't going to color code, but I don't know if it helps or not. You're not here, so it's so hard. So this is negative 2 minus 1, that's negative 3, which would then be negative 1 times negative 3, which is 3. So there's 2 different answers for that one. And now we're on to, sorry, I keep getting distracted because I dropped my earring and I was looking for it. My apologies. So F of X in part F is negative 3X plus 1. G of X is 9X and H of X is negative X squared. Now remember, that stands for negative 1 times X squared. So you do your parentheses first and then multiply by negative 1. And they'd like us to find F at G at H at X. Now I know that looks hard, but start with the inside. Okay? Start with inside. So I'm going to plug, this is how it's going to do. I'm going to plug H into G, and then I'm going to plug that result into F. Always whether letter X is. So I'm going to start with the inside. So G at H of X would equal 9 times negative X squared, which would give me negative 9X squared. Then on the outside, now I have F, negative 9X squared. So I'm going to plug that in where the X is. And I get 27X squared plus 1. I know that's kind of crazy, so hopefully you follow along. Hopefully you ask me questions if you have questions. For homework, we're going to skip numbers 12, 17, 21, 24, 26, and 28. Thank you.